Welcome to qnawire.
Okay, we've got HCl and Br2 to choose from, and we've got 2-methyl-1,3-butadiene, so that's and 2-methyl, put that there, or cyclopentadiene. There. And we've got to pick one of each and give the major of the 1,2 addition and the 1,4 addition. Well, let's just kind of outline this theoretically, and then we can quickly draw the products from there. When they say 1,4 and 1,2 addition, 1,2 refers to the fact that you count the number of carbons away from the carbon that you're adding to. So say 1,2 would be adding, for example, HCl across this bond, 1,2. Whereas 1,4 addition, we would say 1, 2, 3, 4, and add HCl across that series of bonds, right? So I'll give an example of the 1,2 addition first. For example, I'll step through the mechanism so we can see why it is that it happens the way it does. Get attack on the proton from the double bond. So that double bond will be destroyed, leaving behind the carbocation on whichever side is more substituted. And the Cl minus. So let's color code things here so you can see. That we've added a proton here. That's what happened in that last step. And now the Cl is going to add to the carbocation. And this is an example of 1,2 addition, because the carbons that we added things to are 1 and 2. And I forgot to draw these double bonds in here, sorry. Okay, now let's look at the example of 1,4 addition. With the same molecule, we'll do it again with HCl. So this will be more likely. I'm going to show this happening on the other side, just because it makes a little more sense. Let's suppose that this first step happened over here, giving us, instead of that tertiary carbocation, right, the more substituted side is over here. This allylic carbocation. And at this point, we could see this double bond migrate over. Still got hydrogen here. And we've got a carbocation here. You may say, hey, we can't have a primary carbocation. In fact, it is okay if that carbocation is allylic, because it's stabilized through resonance, as we just kind of shown by the flopping of this bond. It's stabilized by resonance, at which point the chlorine will come in and add, right? Finally giving us our final product with hydrogen here and chlorine here, which, if you were to count the number of carbons, 1, 2, 3, 4, is where we get the name 1,4 addition, right? Okay, so now that's the 1,2 addition product of HCl, and this is the 1,4 addition product of HCl. It's also possible that we could get a 1,4 product, 1,2 product that looks like this, just by adding 1,2 to that bond directly. In fact, there's a number of different options. If we had initially added to this bond, this double bond, but then had this flop over, for example, we would have gotten H and Cl on opposite sides of the molecule. Okay. Choose one reactant from each group and pick their major products with a 1,2 addition and 1,4 addition. Right. Okay. So then, yeah, we've shown a few different options, but what we want to do is pick the major products of this one, right? So let's step through that. Let's use the same example and we'll step through how we decide what the major, we've established that there's multiple 1,2 and 1,4 addition products, but how do we decide what the major ones are? Okay, so for 1,2 addition, let's discuss that. Now there's two options, as we said, as to which side hydrogen can initially add to. All right, we can add to this side. Creating a carbocation here and adding our hydrogen here. The other option adds a hydrogen here and a carbocation here. So then the question is, which of these two products is more stable or favorable? It's the one that places the carbocation on the tertiary carbon as opposed to the secondary carbon. So if one of these was the major 1,2 addition product, it would be the one that starts out with this intermediate because it's more stable. And that after the chlorine adds, we will get this product. So this would be the major 1,2 addition product because it proceeds through the most stable intermediate. We can make the same arguments regarding the 1,4 product. So let's step through that. Okay, we've established that this is one option. In which we can then follow this up with migration of the double bond. Finally leading to chlorine adding. Giving this product, or the 1,4 addition can proceed beginning with addition of hydrogen to this double bond, yielding the following intermediate. And once again, we're comparing which of these is the more stable intermediate and more likely, to be traversed through. And again, it's going to be this one. This is going to be the more stable of the two possible intermediates, and therefore the product that we get from this will be the more favored product. So this would be the major 1,4 addition product.